Hi everyone, my name is Hafiz. Let's start with the project. Zomato Restaurant Clustering Project. Executing the wrap up. Here in the first phase, we will import the essential libraries like Pandas, NumPy, Matplotlib, Seaborn, Skitlearns. For every essential libraries, we are going to import this one. And let me define the problem statement. Like Hyderabadi Gochivali food scenes is a crowded, price sensitive, and decision making needs to evidence based on the ways like segment restaurants, price prevent qualities, spot white opportunities. Okay, our goal is to turn the Zomato metadata of 1,000 plus reviews and which has the 100 plus restaurant in a row of 32 raw columns and 10K reviews with the raw 7 columns, and the data quality is to check the nulls values in the restaurant files and etc. The key responsibility of the processing the future engineering like cleaning cost strings, tokenizes, cuisines collection, aggregation review, dry business scores, price branding, and stat band scalar on the 10 final futures. Let's move on to the phase 2. Here with data loading is taking place and initial exploration about data. Here we will import the files and explore the data sets like let me show. Here is the overview what the restaurant data set has in it. Okay, like this is the phase. This phase is crucial of getting first look at our data set, understanding the structure before starting and cleaning the analyzation of it. In the third phase, let's run it. In the third phase, you will get to know the display understanding of the data sets beyond just their shapes and column names. Here, what it does, this code, what it does means it prints the detailed information about the restaurant data using a data frame. It then provides the statistical summary of the numerical columns, and it repeats the same and step by step data frame. Finally, it checks for the missing value in both data frame using is null dot sum and print the count missing value. This phase is essential for identifying the data types, potential outliers, and missing information that you will need to address the data cleaning and understanding of the data. Next, we will see the output I have given. The output I have generated like data exploration, columns, null counts, D types, and static summary of that one mean, mode, median, out, max. Reviewing data explorations. Statistical summary we have the missing values like collection has 44 missing values, and reviewing data missing values like reviews are 38, pictures, time, metadata, rating, and etc. Let's move on to phase 4. Phase 4. In the phase 4, data cleaning and pre-processing functions we have used here. Let's break down to the function is there. Like a clean cost column, cost string is there. These functions take the string representing the cost extraction of numerical value using a regular expression. It handle potential value missing by returning np.nan. This function attempts to extract information about opening hours and timing string. This implementation it simply counts the occurrence of two or as a proxy number of time period mm, mentioned here. Let's run this one. After cleaning the restaurant data, let's move on to phase 5. In the phase 5, first I will run this one. Phase 5. Review data aggregations. This is where individual review enters and summarizes providing metrics for each restaurant. It starts by converting the rate column In the review data, data frame of numeric types, arguments ensures that any value that cannot be converted the number are turned into nan, not a number like any nan. Uh, this aggregation review the data provides the key performance indicator of each restaurant. Performs indicator of such as on customer feedback, which will be a valuable feature of for clustering, like review data aggregation successful, aggregated review data shapes. Okay, let's move on to the what phase 6, merging the two data sets. Here, the merging data sets are involved. Ah, this is where the restaurant information and the aggregated review of datasets are combined into a single data firm for future analysis. Let's break down to step by step. It merges restaurant data with data frame with a review aggregated data frame. Okay, and then it counts the missing cost matrix values filled with a median cost of value restaurant, missing time period values filled with one here. Finally, it prints the confirmation message that the shape of the result final data frame. Now it contains necessary information of each result, including characterized and aggregative reviews of the matrix. Let's move on to the phase 7, like future engineering. Why it is required? This phase is creates new potential for more information. Future from the existing data helps to improve the clustering results. Let's break down to this code. Let's first run this one. Here is the result future engine cost numeric and all. Let's break down. It's a popular score, a new feature of popularity score. It calculates multiple rating count, average rate, and divide into 5 steps. Attempts to create a single metric that capture both the volume and quality of the review. A variety of scores like A score, B score, C score, depending upon the restaurant and the review they have provided, and the price category also included and a rating category also included in this one. Finally, handling the missing review, missing values, like a loop liberates through the cluster data column and fills any remaining missing values with the median of the column. This ensures the clustering algorithm, which typically cannot handle the missing data, will work correctly. Finally, it prints the message like confirming message of the list that future will be provided like this as well. Let's move on to the phase 8. In the phase 8, data scaling and uh, preparations. This is a critical step before applying most clustering algorithm, as they are sensitive to scale of the futures. Here, let's break down step by step. Here, what happens? It initializes a standard scalar object from the skitler. The standard scalar and skitler features by removing this means scaling of unit variance. This results the data with a mean 0 and the standard deviation of 1, making the future having similar influence of clustering process regardless of their original scale. It applies the scalar to that clustering data from using this fits the scalar data, calculating the mean and the standard deviation of each feature. Then it transform into a numpy. This results providing the scalar scaled data. Okay. By scaling the data, we ensure the future with the large value don't dominate the distance calculating the cluster algorithm, allowing the algorithm to find a cluster-based undefined pattern in the data. Let's move on to the phase 9 then. Sorry. Clustering pipelines. K means is equal to K, C load 0.4. This is the What module evaluation of key means wins on cohesion and improbability. EDA visualization chart produce like cost histogram, rating bar chart, cuisine variety bars, collecting count bars, cost versus rating scattering. Okay, let's move on to phase 9. I will run this one first. Phase 9. It focus on applying a K-means algorithm to scaled restaurant and finding an optimal number of clusters here. We will find the optimal number of clusters. Let's break down step by step. First, initially, empty list is created and the stored result of elbow method. We will use elbow I'm saying, elbow method and cumulative score is calculated. Okay. Then the visualization of elbow method and squarely scores here you can see in the charts. This is elbow method and the silhouette score. And third is a determining of optimal K fitting final module. Okay, what fits in the module and visualization of K means clusters. I will visualize this one. Make some okay. Okay. This K means clusters of PCA visualization. A model created to reduce the dimensionality of the scale data of two components. Okay, by visualization, it helps to for high dimensionals data in a 2D space. We can retain much possibilities. Then we'll move on to this display plot graph. This is plot graph or display. This cell effectively applies k-means clustering, provides a method to evaluate appropriate appropriate number of clusters. What are the appropriate number of clusters are present? And the visualization result in the resume the dimension space. Okay, let's move on to the phase 10. Here DB scan clustering implementation. DB scan density based spatial clustering of application with noise is a cluster of algorithm that group together points and closely packed together, making a point that lie along with the low density regions as such as outliers are present and noise are present. Let's break step by step. DB scan requires two main parameter: EPS, the maximum distance between the two samples of the one to be considered as in a neighborhood, and others. This code attempts what I have written. This code attempts to find a suitable EPS value using a k distance graph method. It calculates the distance of each point and fourth nearest neighbor, a common rule of thumb. Okay. Then fitting a final DB scan model. A final DB scan for is fitted using a selected best EPS scale data and cluster label assigned to the model. They are stored and added a new column like a DB scan cluster to the final data of a data frame. Its results in it counts the number of unique clusters found, it counts the number of noise points, it prints the number of clusters and the noise points found. Later visualization like first the second of DB visualize the DB scan cluster in a 2D pack space. Okay. The third subplot shows the bar chart cluster size distribution, including the count of the noise, how much noise is present. Okay. This cell provide the implementation of DB scan clustering, include the method for parameter selection and visualization of the results of cluster characteristics. Let's move on to the phase 11 here, hierarchical cluster implementation. This method build a hierarchical cluster either by merging a small cluster or large cluster. These code focused on algorithmic approach. Let's break down step by step. Uh, Find the best linkage method. Here, in hierarchical clustering, using a linkage method to determine the distance between cluster, common method are word, complete, and average. Okay. Next, we will move on to fitting a final hierarchical model. What the model represents here? Here, the model represent I did it. Model. Okay, a final algorithmic clusters method. It uses a linkage, best linkage method like what I have used here. Okay. Uh, this cell successfully implement the hierarchical cluster, exploring the different linkages. Method provide visualization, understanding clusters structure, and compare with the results. It compares the result of other clustering algorithms, basically. Okay, let's move on to the phase 12 model evaluation and compression. Okay, this is a crucial step. I'm saying more like a crucial step, but this is the most crucial step. Okay, it accesses the quality of clusters generated by the different algorithms, like I have used k-means, hierarchical, db scan, etc. Okay, let's break down. It defines function like ev. Where is the function? Ah, evaluate clustering. Like it evaluates the matrix. Like evaluate clustering, the text, the scale data, cluster label, and the model name as an input. These function calculate the common clustering evaluation, like cumulative scores, measures how will each point is assigned to its cluster. Higher score indicates better defined clusters. Okay, like here's the output. Model evaluation. The k-mean silhouette score is 0.57. Clinic harassed. Harba's score is 35. Davis n clusters noise is 0. In Davis coin 101 the noise is present, etc. In the phase 13, we'll move on to the phase 13 now. Let's run it. Yeah, it started. Phase 13. Mm, okay. Here, like cluster analysis and interpretations take place. This is where you dive into a characteristics of a cluster, identifying the chosen cluster algorithm. In this case, k-means based on the previous evaluation to understand what it makes each cluster distinct. Analysis of k-means cluster, like it groups the final data frame by key means cluster column. For each clusters, it calculates the mean and a standard deviation for several key features like cost numeric, cost rating, rating count, cuisine count, popularity score, etc. These results are routed into two-dimensional, placed and stored in the cluster analysis data frame. Okay, like visualization cluster characteristics, it creates a figure with the grid of supports of two rows, three column visual and distribution of key features across the k-mean clusters. Okay, like you can see here, cost numeric by k-means, cuisine numeric by k-means, average, rating by k-means, collecting counts, etc. Let's move to the phase 14. Yeah, is the business insight we have created, like business inside of clustering interpretation, number of restaurant 100, average cost 872, cluster profiles, etc. Here is the last step. What I mean is the phase 15. It is very important to store. After calculating, we have to store every data and export into separate files. This phase tells us how we saves the data and export into another files. Like uh, actually, this is a final step where the result of cluster analysis are saved in the future, used for reporting. Okay, saving result like it prints a handle indicated that result brings saved and determine the output columns, final data, etc. This cell ensures us the valuable insight gained from the data clean, future engineering, clustering phase, and prevent easily accomplish the finals. This is where the final results are saved and missing none values. Let's move to the next one. Okay, conclusions like missing null value, duplex, eternary, etc. Thank you.